The cosmos is vast, and for centuries we've wondered, are we alone? Now, science is closer than ever to answering that question. On September 17, 2025, NASA's Perseverance rover sent back a message, not in words but in Martian soil. Acting NASA Administrator Sean Duffy called it the closest we've come to discovering life on Mars. Perseverance, our robotic explorer, has spent years searching for signs of ancient life, drilling into Mars's crust and analyzing its secrets. In a recent sample from Neretva Vallis, an ancient river channel, it found something extraordinary, not a fossil but a microscopic clue, hidden in the chemistry of the soil. Two minerals, vivianite and greigite, were detected, minerals that, on Earth, are closely tied to life. This isn't proof of life, but it's a powerful signpost, a hint that ancient Mars may have been more than just habitable. The red planet's whisper has grown louder, urging us to listen and continue the search. Our understanding of the universe may be on the verge of transformation. So what are vivianite and greigite, and why are scientists so excited? On Earth, these minerals are almost always linked to living things, byproducts of life's processes. Finding them together in an ancient Martian lakebed is like finding a footprint in the sand. Vivianite is a hydrated iron phosphate, often forming in fossils and even graveyards, tied to organic decay and phosphorus, a building block of life. Greigite, an iron sulfide, is produced by bacteria, including those that use it to navigate or survive without oxygen. Both minerals are signatures of microbial activity. Discovering them together suggests a complex, possibly biological environment. The pattern is compelling. Vivianite points to organic decay, greigite to microbial metabolism. Perseverance didn't just find a clue, it found a collection of clues, telling a story of a potentially living past on Mars. The scientific community is electrified by the possibilities. To understand the Martian discovery, we look to Earth, our only known home for life. Here, vivianite and greigite are part of a dynamic system, fingerprints left by microbes in ancient lake beds. Imagine a deep, calm lake bacteria thrive in the sediment, producing greigite as a byproduct. As time passes, phosphorus from decaying organisms reacts with iron, forming vivianite. This sequence creates a recognizable geological pattern, a biological signature. The Martian sample from Neretva Vallis shows a similar pattern, a core of greigite, surrounded by vivianite. This structure mirrors what we see in biologically formed minerals on Earth. The process, called extracellular electron transfer, lets microbes breathe minerals, shaping the mineral record. Seeing this pattern on Mars bridges the gap between worlds, hinting that the same rules of life and chemistry may have applied. It's a breathtaking moment for science. Neretva Vallis isn't just any spot on Mars, it's an ancient river channel that once fed a lake in Jezero crater. These environments on Earth are where life often begins. The sample revealed a ring of vivianite with pockets of greigite, like leopard spots. This isn't random, it's a sequence that suggests a changing environment consistent with biological processes. The big question, could this pattern form without life? Scientists will now try to replicate these conditions in labs on Earth, testing if such mineral patterns can arise abiotically. The answer will determine if this is a hint, or the first confirmed biosignature beyond Earth. Regardless, this discovery proves Mars had the right ingredients for life: water, phosphorus, and iron minerals. The red planet is no longer just a hope for habitability. It's a world that had all the right conditions. Now, we must ask, did Martian microbes ever appear? This discovery doesn't just fuel our imagination, it changes our plans for Mars. NASA's sample return mission is slow, but the urgency of this find has shifted priorities. The consensus send humans, the best geologists, to collect these samples. Astronauts can do in days what robots take years to accomplish: survey, sample, and analyze with intuition and skill. The core samples Perseverance drilled will wait for the first human explorers. These astronauts won't just plant a flag, they'll search for life's evidence with Martian dust on their boots. The whisper from Neretva Vallis is now a call to action. Our quest for knowledge and the answer to, are we alone, may soon be found in Mars's ancient riverbeds. The next step belongs to us.